for accepting the invitation and welcome to this session.
Thank you, ma'am. Okay, before I start off, let me first share my screen. All right, so this is my profile. Just a quick intro about what I do and what basically I am. All right, so this is me, a lot younger version in the image, but yeah, now I'm getting older. So my name is Sharath, and I'm a director of DAY2. It's basically in the space we completely focus our work or our efforts in the space of AI. We do IR 4.0 implementation. We are specialized in the space of analytics, cloud computing, and we also have specialized IoT experts. They basically deal with the IR 4.0 implementations, especially with the sensors and all that. And we have worked for the clients like um, Bharti Cements, we can talk about Coca-Cola, we can talk about various reputed organizations in the space of life sciences, healthcare, etc. We have a big pool of clients, clientele. We're also global training partners with respect to Microsoft. We are accredited with IBM. So when I say we, I'm representing InnoDataTix as well as 360-digit MG, because 360-digit MG is completely focusing into the uh, upskilling, training perspective. And InnoDataTix is into the consulting. We cater to projects and software development in InnoDataTix, service-based as well as development, software development-based organization. So that's a quick intro about me. And so let us try and understand few things about analytics. I'm pretty sure you might have attended various other sessions pertaining to analytics, data science, and data analytics. But just to have a quick overview of this, if I talk about analytics, I have a habit to write a lot on the screen. If you give me a whiteboard, then I'll keep writing on that. So yeah, please bear with me on that. And if you do not understand my handwriting, sorry, I'll try to read it out. So yeah, that's my handwriting. I'm really pathetic. I'm like a doctor, not the PhD scholars. I'm talking about the actual life sciences healthcare related doctors. So yeah, that's my handwriting. So let's talk about analytics here. When we say analytics, we are trying to deep dive into the data. We churn the data, or we say we torture the data, and then we try to extract meaningful information, right? We churn the data to get information. So if I have to represent a triangle here, okay, let me try and draw a triangle. We call this as knowledge pyramid, or you can say information pyramid. Everything starts at the low level, and this is the key. This is your raw data. We have raw data. Now this raw data contains a lot of information, and that information has to be extracted. Now why we need to do this? What will I get if I take information? Right? I will get knowledge. Right? If I take information, then I become knowledgeable, right? I have more knowledge. Now from this knowledge, you will become wise, right? So this is basically your pyramid, knowledge pyramid, we call it as. And in order to achieve this, there are certain quantifiable techniques that we need to apply to work with this data. Very simple, again, logic. If I give you a data, any data, right? Let's assume students' data or employees' data. If I give you 10 records, or 10 observations, we call it as, right? Either records or we call it as observations. When you look into this data, you would be able to manually analyze it, right? You will tell, probably you have student marks. You'll be able to look at the marks and you will tell which student is performing really well, which student is not performing well. And along with that, if you have various other features or factors, you would be able to analyze the profile for that particular student. 10 records, manual job. What if I give you a million records? That means I have 1 million students' details. What should I do? You will not be able to manually work on that data, right? That's not possible. We humans have logical thinking capability, right? But we do not have computing capability, at least not to an extent where our computers can do, right? So here, from all these concepts, right, what we are doing is we are taking the help of a computer in order to extract this meaningful information that we are manually doing, right? So all the computing will be done by your computer. But what it has to compute, as a computer is a non-living thing, it doesn't know what it has to do. So you would basically give that logic to the computer and extract the information by doing the computing. This is basically the approach. I mean, the existence of computers basically is for this purpose, right? Now, let us try and understand what is the difference between a traditional programming. Now, we talk about computers' existence and all that, but what is the difference between traditional programming that we have been seeing all these years compared to machine learning programming, which is the most popular approach nowadays in the industry, right? Everybody is speaking about machine learning, deep learning aspects. What does machine learning actually mean? So this explanation that I've given here, right? This is your traditional programming. So what we do in traditional programming, we take objects or data, and then as a human being, we have that intelligence in our, in ourselves. Using that intelligence, we write a logic. That logic is written in code, right? Some language which computer understands. We call that as a function, or you can say some logic is written to process this data. We pass this to our computers, and these computers would do the calculations and they give us the results, right? This is your traditional programming. All these years we have been doing this. But of late we are hearing machine learning, right? So what exactly is machine learning? Now, the approach of machine learning is we have data, we have object. But for machine learning, we take historical data. We look into past, right? We take this historical data, and if you look into the historical data, you already know what is the outcome. That means you know results. You know the data, you know the results of those events. We pass this to the computer now. Now we are expecting our computer to come up with a mathematical function, a mathematical logic, which can explain the relation between the input and output. If you can identify this function which can represent the closest possible relation between the input and output, then we can use this mathematical function to do predictions, right? So again, taking one step back, we talk about data analytics, which can be classified into 4 different stages. We talk about descriptive, and we also talk about diagnostic together. This is something which, right, every business does. In fact, prehistoric, maybe probably we talk about pyramids, construction of pyramid time, right? Descriptive and diagnostic analytics is there. We're just looking post-mortem. We're trying to look into the past and trying to understand what we have done, how we have done, what is the outcome. So this is not a big, right, revolutionary area. This is there already in the industry. But can I try and do my business a favor so that it gives you good results, better results, good profits, right? That's the ideology that we need to have, or any business will have. Now, in order to do that, right, that means I want to do some strategy, I want to do some planning and implement ideas to drive my business into profits, right? And it profits. But what ideas, what would be the best solution that you would implement is a question. Unless until you implement it, unless until you get the returns, you would not know whether this is profitable idea or not. So here, in this space, right, we have something called as predictive analytics. This is descriptive and diagnostic. We are looking into the past, and here we are talking about predictive analytics. Predictions. If I can upfront tell what might happen or what may happen in future, if I can guess that or if I can measure that, then the planning that I can do would be more appropriate. I can also guess what profits I can get. So this predictive analytics can be done using this function. So your machine learning algorithm, you're training your machine so that it does the intelligent computing on the historical data, so that when new data is given using this function, we can predict the results. The event did not occur. We are predicting these results. This is your machine learning approach. I'm pretty sure most of you people are already aware of this logic, but if you have any novice people who don't come from this background, or if you are not familiar with the terminologies, then yeah, hope this explanation is giving you a clarity on what exactly is machine learning algorithms. Now, I know I've come from a training field, right? I have a passion to train people. I love it. And I interact with a lot of people, especially working professionals who come from different streams, different working areas. They keep always asking me a question on, hey, is analytics my cup of tea? Will I be able to do it? My simple question, written question to them is, do you see digital data in your working area? Do you see data? The same question I would be asking you people. Do you see data? Whatever the work that you are doing, especially after pandemic, we are forced to use knowledge, and based on that knowledge, we become wise. Right? Now, if you're wise, obviously your decisions would be more appropriate to your business benefit. And analytics is something which can be done. I would right, segregate analytics based on courses. strengths. Right? People, individuals, they have their own core strengths. Be programming the data and extracting languages like Python, which is the most popular tool right now in the in the industry. They can basically manipulate good with mathematics and statistics. We need this because all the concepts in analyzing the data derive the mathematical functions that I'm talking about. Remember, I just mentioned this paradigm. This is a framework for machine learning, right? So if you have to define this mathematical function in a very simple way, we write it as y is equals to f of capital X. This is called as base function for your machine learning algorithms. So here we are representing a mathematical function which explains the relationship between input, this is input, and this is your favored output or desired output that you are interested in. So people who are very good with these mathematical and statistical skills, they can try and figure out what mathematical function can be used. This is another core strength. And one of the core strengths which basically helps businesses is the business understanding itself. There are people who really understand businesses very well. I should say business acumen or business understanding. This is the third type of, I should say pool of people who also can become data scientists. Then there are technological people, there are people with good communication skills, right? Good analytical thinking, logical thinking, basically. So there are different core strengths, but I would probably segment a data scientist into one of these 3 or 4 segments. I would say others. Right? These are the 4 core areas. Now you decide what is your core strength, and then focus on treating your data with respect to that core strength, and that should solve your business problems. Right? Now this is at a high level, friends. Now let us also talk about, this is important. Okay? Anything that we deal with analyzing the data has to be in 2 forms. One is descriptive analytics, and the other one is predictive analytics. Okay, broadly, I put it in descriptive and predictive. For descriptive, you'll not have this mathematical representation, not required. But for predictions, yes. Because you're trying to predict this value specifically. And when we try and apply this mathematical equation for predictions, the functions that we are defining, right, has to fit into the data, or I should say the data should fit into this mathematical function in such a way that if I pass the historical data, input data into that mathematical equation, I should get y. But in order to achieve this, we have 2 different approaches, right? So this mathematical function can be approached or derived in 2 different broad ways. The first approach that we talk about here is called as predefined mathematical formulas or equations, statistical models. We call them as statistical models. These are nothing but predefined equations, predefined mathematical equations. Right? And the best and the very, very simple mathematical equation that you can imagine or think of is equation of a straight line. Most of you remember, right? Y is equals to mx plus c. Right? This is something we ask students, or we basically, when we were students in our school days, we used to have that graph sheet. And in that graph sheet, we used to draw this equation wherein we draw a straight line like this. This is x-axis. This is y-axis, right? And this point is called as intercept. In any data point that we have to represent on an x and y space, a two-dimensional data, then that data point can be represented on x-axis as x1, y-axis as y1, right? So we represent this as x1 comma y1. So here you can see on x-axis it is 0, on y-axis it is c. So you can represent this as 0 comma c, this data point, and this distance that you're seeing is your c. This is called as intercept or constant, right? Because if I have to represent the value of y with respect to x, then I need a value on x. If I put x as 0, I don't take x at all, then my y would be c, right? So it's a constant value. It's not getting affected by this variable. But if I have some variable x, then that x is affecting y, right? And this m that you're seeing is called as slope, gradient, right? At what influence or what is the effect of x on y, right? What is the gradient of, y gets influenced by. So this is the simple mathematical equation. Now why we are talking about this, right? So if I have some data, let's say we'll talk about a small data set only for interpretation. Let's say x and y. At two-dimensional data frames, okay? Practically, we'll have to work with multivariate data or multiple dimension data, but for interpretation, for understanding purpose, we are taking 2 dimensions because we will be able to visualize it here. So if I take this x and y, assume x is number of hours a student is preparing. So let's say preparation time in hours. And this is, let's say, the marks secured. Assume. So this is marks and this is preparation time. Okay, let me erase this. It's not visible here. So if a student spends, let's say, 5 hours, then he would get so much marks, right? Let's say some marks. Let me draw it here again. I'll draw it freshly. So I have 5 hours investment in preparation by a student. Let's assume that he is going to get so much marks. 10 hours he is spending. What happens to the marks? Obviously, it has to increase. So it is increasing. 15 hours, 20 hours, so on and so forth. So as and how x value is increasing, the value of y will also increase, keep increasing, right? So that means there is a relationship between x and y. Now, can I represent that relationship using this mathematical equation? Oh yes, I can, right? So this way we have to come up with this equation. But what is this equation? You're saying y is equals to mx plus c, but we need to see what is y and what is m. Only then I will be able to get this equation, right? This equation that you are seeing can be represented as y is equals to f of x. Y is a function of x, right? So mathematically, we are representing the relationship between x and y here as x increases, y is increasing. So there is a constant relationship between y and x. Mathematically, we have to prove that. But in practical scenarios, you'll not have a data which is perfectly like lying on a straight line. Your data might be like this. It will be scattered, right? It will be scattered like this. Okay. So here we are trying to draw a line which is best fit, and that best fit equation is your prediction, right? Prediction equation. So this is your predefined statistical models. I mean, the logic is based on predefined mathematical equations. Next, the second approach that we can take here is black box techniques. The black box technique means we do not have any mathematical equation upfront defined to explain the relation in the data. For example, let me try and erase this. So this is my X and Y. I'm talking about black box, right? So what if my data is having a relationship like this? Now, if your data looks like this, mathematically, we don't have any equation which can explain this kind of a relationship, right? Not possible. It's not there, not defined. So when we have this kind of case, your predefined mathematical equations would not come come off any help. So we are going to develop a mathematical equation based on the data. And this equation that we are talking about, of course, is again represented as y is equals to f of x only. But that equation cannot be explained. That means what is C, what is M, we cannot explain. Non-explainable or unexplainable or uninterpretable model. Right? Black box means we cannot explain. So what we do? We take data, we take results, and we pass it to the computer, and we get a mathematical function. Now this logic is a foundation of your artificial intelligence. Because your computer in its raw form does not have any brains. But the data is giving us its some brain so that it can identify the mathematical function. Right? At a very crude level. These black box techniques, when we talk about black box techniques, in the current day, are nothing but neural network. Neural network concepts. Right? And this neural network algorithm is developed to simulate a biological brain. Right? It is developed to simulate a biological brain. How many of you are actually familiar with neural network concept, or how many of you actually know what all we are discussing here? Let me see the response. I'm not sure. I have no idea on what all things you are familiar with. So let's see. How many of you are familiar with all these concepts? You can unmute yourself, or you can message in the window.
Sir, I am familiar with this, sir.
Great. So not many are familiar. Okay, so I'm not wasted my time. And your time, of course. All right. So neural network is an algorithm which tries to simulate a biological brain. Right? Mathematically, can a computer mimic a human brain? Can I mimic a human brain? When I say mimic a human brain, we are talking about how a small, right, learns things to do right, the same task in a better way. For example, I have a 5-year-old kid. Right? Now he started learning on how to eat his own food. I'm giving you a small example. So if you talk about a small kid, he would not be able to control his hands. He would not be able to grab food. He would not be able to eat it. But what he is doing is he's experiencing. He's starting to do it. Right? He will try to hold the food. He'll try to put it in mouth. He will see elders how they are doing it. When he is trying to eat it, he will know maybe first he will not be able to grab it properly, but practicing, he will figure out on what is the best way to hold the food, then how to put it in mouth. So practicing, right? So experiencing. The idea of this experiencing by doing things is something is being mimicked by artificial neuron. Okay, we call it as a network of neurons because our brain also is consisting of a network of neurons. So we try to replicate this network, right, for learning or training process. So when we talk about neural network, we need to look at how an individual neuron works, right? A human brain consists of more than 85 billion neurons. We're talking about one neuron's process. How does it actually train to give us this intelligence that we are possessing? So this, assume, is an artificial neuron. We're trying to replicate an individual neuron in our human brain. Now, when the information is being passed to the brain, in brain, a neuron is processing that data as a computer. So data is getting fed into the brain, into the neuron, and neuron is processing that particular data and then gives you an output so that you do the actions. For example, I hold this hot cup. Let's say this is a very hot cup of tea. I'll hold it like this. What is the data that my brain is processing here? Heat. Right? When I hold the hot cup of tea, my fingers are reading that heatness. And that is all the way in the nerves, right, is passing through my brains. So the nerves that are capturing the data and then passing to the neurons are called as dendrites. It's a terminology in the brains and all that. But that heat that is being captured, right, it's getting accumulated into the neuron. This is your neuron. So we keep accumulating the data into neuron. And once the data is getting accumulated, every neuron has a threshold level, right? So it can store the data. It can store the data like this. It can store, right? But after a certain level, let's say this is the threshold, beyond which there will be no space. Every neuron have a threshold. Now, once the threshold level is reached, that means I'm holding the cup, the information is constantly being fed into my brain. That means my brain is recording this entire data, but only till certain level. Because after that, my neuron cannot store any data. That is when what happens? I will drop the cup. Because your neuron, once it is accumulated with the threshold amount of data, it fires an output. Neuron will fire an output. That's like processing, right? So you output. Drop. So this is input, this is output. Your neurons process your data. So the same logic is applied for your computer as well. So this is your neuron. We take input. Let's say this is x1, this is x2. From your data set, right? You'll have a data set. You're passing x1, x2, and your output variable. So we give x1, x2, and along with this x1 and x2, we also add some weightage. The neuron will take some weightage. All this gets accumulated. We have a function called integration function. This accumulates all the data. And then once it reaches to threshold level, the output is fired out. Now this calculation is called as the predicted result, a fitted value. This output is triggered using an activation function. We call this as activation function. So your brain also fires an output only when the accumulated data, the collected data is reaching to a certain threshold level. So here also here in the artificial neuron, your data gets accumulated and then an activation function is triggered so that you get output. Right? This is how your neuron works. But if I have to represent this mathematically, then I would say my y hat can be explained as a mathematical function of dot product of x, which is input, and the weight that we are assigning. Okay, there will be also something called as a bias. We'll also have something called as bias. We'll add that. It's like constant. In y is equals to mx plus c, we have c, right? A constant. Same way here also we have bias. But where is the training? You get output, but is this output equal to your original data? We don't know. So we measure the difference between the fitted value with the actual value. This difference tells us how wrong we are doing the task. So we look into the historical data, or we try and replicate. I mean, the kid is looking at their parents, for example, and is trying to learn what is the mistake he's doing. He'll find out that mistake, right? So that is termed as error here, and it is represented as actual value minus predicted value. Predicted value is represented as y hat. So this is the error. Now by looking at this error, the kid would try and correct himself. So we pass this error as a feedback. Right? That means the kid is fine-tuning his work, whatever the task that he's doing, he's adjusting his task. Isn't it? So your artificial neuron also is looking into this error and making certain adjustments into this equation so that it can recalculate the value again. So in this case, input will not change, right? Input will not change. The only thing that can change in this equation is these weights. Originally, it is randomly triggered. There is no specific value predefined for W, it is randomly triggered. But based on the error, we fine-tune it, we adjust that weight. In order to redo the task and achieve more accurate result, that means we are trying to reduce this error by repeating the task iteratively. Repeatedly, non-stop, you keep doing this until you reach to a satisfactory level. You need to reach to a satisfactory level, right? Until you keep doing this, right? This process is an iterative process, which is known as perceptron algorithm. Perceptron algorithm, and this is the foundation of your black box techniques or your neural network techniques. The perceptron algorithm. Individual neuron is getting trained itself to achieve good results by repeatedly doing the same task again and again and again and again and again to reduce the error. So we are trying to minimize the error. We're trying to minimize this error. Right? So hope this logic is clear with everyone. Any questions, anyone? Do we have any questions for this? Okay, is it making sense or am I boring you? You can be very vocal and please ask me questions.
Sir, absolutely fine, sir. So we are getting a lot of new things also, sir. Thank you.
Great, thank you. All right. So let us proceed. Now, that's one aspect, right? We talked about the base equation y is equals to f of x. And we've understood there are two ways to handle this. One is using statistical models which can be explained. We call it as predefined here. We call it as unexplainable or black box techniques, which is nothing but neural network. Now, if I have to use this predefined equations, explainable mathematical equations, or if I have to come up with this y is equals to f of x equation, my data has to be in structured form, right? My data has to be in this table representation where I know what is x and what is y, right? This representation is called as structured representation, right? Now, what if your data is unstructured? So I'm training my computer or my machine on the structured data, and the process is called as machine learning. Your machine is learning things. Now, what if we have unstructured data in place? Now, the difference between structured and unstructured to start off with, a lot of people say structured data is a table representation, unstructured data cannot be represented in table and all that. But what exactly is structure? Is it this representation or is it something else? If I have to represent this in a table, then I also have an Excel file or a CSV file, right? Does that mean, is this structured data? Can I define it as a structured data? Not really, not really. Structured data actually means a proper data model. That means I need to have definition to the data so that your computer can understand the data. Ultimately, your machine has to understand the data to process it, right? And if your machine has to understand the data, there should be proper definitions that your machine understands with respect to the data. What are those definitions? We already know, everybody knows about it. These definitions are nothing but the data types. We're talking about the data types. Whether the data that I'm storing in this particular columns are integers, or they float, or we also call it as double, or decimal points, or is it a character data, non-numeric? In programming languages, in SQL programming languages, we also say alphanumeric or varchar, right? Or is it a Boolean data? Boolean means 1 or 0 kind of binary kind of data, right? So these are the definitions for your computer to understand these fields that we have. And the default software that you need to look at is RDBMS system. RDBMS softwares will always have the definitions when you're dealing with or when you're storing the data. That means we define the fields first and then load the data into RDBMS. So structured data is nothing but a table representation of the data with a data model or data definition. And these definitions in the programming terminologies, we call it as schema. So if I have a data set with schema defined, only then I'll call it as a structured data. If I don't have schema, then it is not a structured data. It can either be a semi-structured or you say unstructured. Semi-structured or unstructured data. Semi-structured, the best example is your HTML or XML programming code. HTML or XML data will have a data module, or I should say data definition. They have specific, I should say tags. They have tags. If you see HTML code, you will see that there are a specific set of tags within which you have content, right? So we have tags, and within the tags we have content. It is not in a structured format. We don't have schema defined upfront, right? But this data, because these tags and contents always follow certain pattern, right? We can take that data and give a definition to it. So we call this as a key and value pair. Key and value pair data. Right? So key is like your, if you talk about table, this header is your key. And the values inside the table are your values. Right? So key and value pair data. And once you have this, then giving data definitions to the keys based on the values is not difficult. Right? We cannot very easily give the data definition. So these are called as semi-structured because we can give the definition and make them structured very easily because of the pattern of the data, right, that we have. Now coming to unstructured data. Sorry? Is someone speaking to me? Sorry, someone speaking to me? Okay, I think no. Okay, so now coming to the unstructured data, friends. Here, very simple. Even if you want to give the data definition, you'll not be able to directly give it. And the best example is images or videos, or you can also talk about audio files, or you can also talk about text data. They do not have fixed key and value pair pattern. So these are the form of the data which cannot have a directly data definition possible. You cannot directly explain the content to a computer. You cannot read. For example, if I give an image to a computer, how does an image be read by a computer? It doesn't know what is an image. Whether that image consists of a human or an animal, it doesn't know. Right? So when you have this kind of unstructured form of data, then how do you take that data and train your machine so that it figures out that mathematical expression? For example, I have images. Very simple example. I have images, and from that images, I need to identify the objects in the image, or let's say humans in that image. So my output is, my output is the objects, and input to the computer would be the images. Right? So if this is the scenario, then we cannot basically, right, directly use the machine learning algorithm or approach y is equals to f of x scenario. So what we do here in this case, because I do not have the data in structured format, we need to give that structure to the data, right? Whether it is image or video or audio or text file, we need to first give that structure to the data. Only then we will be able to work with that by going into a deeper level. We go one step deeper to analyze this data. That's converting unstructured data to structured format. And once it is in structured format, you define this y is equals to f. So this is your machine learning approach, but here you have one level deeper you're going in, right? So we call this approach as deep learning approach. We call it as deep learning. Now both these techniques, ML and DL, both these techniques are part of your data mining concepts, right? And once using these techniques, if I'm able to train my algorithm, train my computer to get a result, then you are basically getting, or you're saying data mining, you're able to do a predictive analytics. But if I automate the process of predictive analytics, wherein I'd say I'll not pass input, let the system take the input, let the system process it, let the system train, and then let the system give me the output. If I have an application which does that, then that is nothing but your AI. Right? Driverless car is an example. Universal example, right? Driverless car. There is no human. We have only a computer which is driving your car. What is the information that it is taking in? A driverless car is taking in an information which is in images, videos, and it also reads sensory data, right? A lot of sensors are fitted across the 360-degree angle of your vehicle, and it reads a lot of that data. Collectively, all this data is giving information to the machine, so that the machine can intelligently take decisions and drive the vehicle ahead. But in order to do that, first the machine has to learn something, right? That is the training that we need to give. So how do we give this training? We simulate those conditions where the vehicle is going to drive. On the roads, for example. If a car is moving ahead, what is the view that the car has? The road, the lanes, the obstacles, the vehicles which are coming towards it, the vehicles which are coming from the backside, the vehicles which are passing side by, people walking there are trees, there are signals. So a lot of such details have to be first fed into the machine. That's called as training process. So we take a lot of images and we train the machine so that it can identify or experience those conditions upfront before it goes onto the road. Right? So it has partial knowledge now. It knows how to drive itself. So we have trained it. But then we are leaving it on the road. You're training it, right? Probably it doesn't, you will not be able to pass all the scenarios, right? It's not possible. You cannot train it. Even today, we are learning about data science in this class. We are not born with all these knowledge, right? So you're learning. Same way, when a car is on the road, it might experience a new scenario altogether. So the training has to be designed, or the process has to be designed in such a way that when new data is coming into the picture, then the machine should learn from its past and take an appropriate decision. Right? So this is called as AI for us, artificial intelligence. No human intervention. Right? Your driverless car is driving itself. There is no human inside it. Of course, the challenge that we are seeing with AI is it is not explainable, and at least till date, we are not confident enough to put our lives right at the mercy of AI. For example, if I give you a driverless car and ask you to hop into it on the traffic road, heavy traffic, in India, for example, whatever the state it might be, it could be Telangana, it could be Delhi, it could be Chennai, it could be any state, right? So, do trust? Do you trust AI system with your life? That's a big question that we need to look at. At least I wouldn't trust, right? So AI has a long way to go, but we're taking baby steps towards achieving that complete AI, right? But the idea is this: take the knowledge, take the data, give the experience to the computer. From that experience, the computer has to take decisions, constantly evolving itself, right? So that's the definition of AI. Now we are going to discuss about deep learning aspects. I will be quickly walking you through what we need to do in terms of images, but we'll not deep dive into it. But I will be talking about certain cases of use cases of handling textual data under text mining. Okay, that's upcoming. We'll take a break now. Post the break, we will start discussing about how do we process images. So it's 11:35 in my watch. We'll connect in 10 minutes. So we'll have a 10-minute break, friends. You might want to refresh yourself. If I'm boring, please grab a coffee and we'll connect in 10 minutes. All right. Okay, all right, everyone. Hope you're back.
Yes, sir.
Great. Yeah, I've just seen my LinkedIn profile. If anybody wants to connect, please, yeah, I would be very happy to connect with you all. That's my LinkedIn profile, and let's proceed. And before I proceed, hope you already know about YouTube channel that we run. This is the link, YouTube channel, and we conduct a lot of live sessions here for learning process, learning purpose. You can also connect to our videos. I mean, you can connect this channel, and we can go through a lot of videos. It's YouTube channel for us, and let us proceed. All right. So we are trying to understand the difference between traditional programming and machine learning language approach. Then we also understood the various core strengths of analytics professionals. And then we've also understood the paradigm of the data science, especially the predictive analytics. And everything boils down to this equation. This is called as a Bayes equation. And we understood that there are two ways to achieve this equation, or the function basically. One is predefined, the other one is black box. For predefined statistical models, we basically go through training the, I should say, training the mathematical equation by passing the input and then trying to figure out the predefined equation. We try the data into those equations. Whichever equation is fitting, giving us that good relation, less deviation, I should say, will be used for doing the predictions. Now, if I have, let's say, the black box technique approaches, then we will not be able to explain things. And those black box techniques are nothing but variants, or it's simply neural network or variants of these neural networks. We do have other black box techniques, but currently neural network is the most popular and the only algorithm which is being used. And we have seen that neural network is basically trying to mimic a human brain learning, where the weights are getting adjusted to achieve the least error possible. And in order to do that, we have integration function and activation function. And here we get error, and that error is the feedback. And this is called as a perceptron algorithm. This is what we've learned. And the difference between machine learning algorithm and deep learning algorithm. Right? So these are the foundational concepts for doing any kind of analysis on data. I mean, predictive analytics, basically. Now, if I have a data which is structured, then we have machine learning algorithms very easy. If you have unstructured data, then we have to apply deep learning algorithms. But when we talk about unstructured data, then that unstructured nature of the data could be in images, audio, or text. Broadly, these are the three segments that we have. We might also have videos, but videos are nothing but collection of images only. So if you understand how to process images, getting the frames out of videos is very simple task. Now, when I have image data, then how do I process it? So here we have something called as computer vision. As the name suggests, you're trying to see how a computer sees the images. And then we also have deep learning based algorithms, which is CNN, deep neural networks. Variant of neural network, we call it as convolution neural network, which is used to process images. Now let us try and understand these concepts at a high level, as I said at doesn't will not be able to deep dive into this. It needs a lot of time. But just at a high level, if I have to try and understand how to process images, the first thing is you need to understand what is an image, right? Image basically is, especially digital image, if I talk about, is nothing but collection of pixels, right? Image is made out of pixel. So collection of pixels gives you an image. And if you talk about a mobile camera, for example, right? We talk about, hey, my mobile has a 13 megapixel image camera. We call it as 13 megapixel camera. What does that mean? An image with 13 megapixels, right? It is trying to capture 13 megapixels. So any image, if you carefully observe, will be made out of pixels, right? Like each pixel will carry some numeric value. 0 to 2, 0 means, sorry, my bad. 0 any image that you're talking about. So image, when you try to process this into pixels, and a color image would be consisting of 3 channels: R, G, B, red, green, blue. It will not work with 3 channels, not required, because it's the same pixel values in different channels, right? So we remove this and we take an image in a 2-dimensional format. So we'll have rows and columns. Rows and columns. Now, how many? I mean, it's a 2-dimensional data, and if I talk about a perceptron algorithm, if I have to train, I would be only working with perceptron algorithm, because training on an image's unstructured data can be done only by these perceptron algorithms. We cannot use statistical models. It will take a lot of time. Previously, it used to happen where we used to use these statistical models to train on these images, 2-dimensional data. The challenge with this is the number of data points that we get. That's going to be huge. If I talk about a data set, right, we will basically have like this. This is y. I'll have x1, x2, x3, x4, x5, so on and so forth. This is your data. So we are mathematically representing y is equals to f of x, where x represents all these variables. Only 5 are there.
Excuse me, Mr. Sharath, I think you've not shared your screen.
Oh, is it? No, I think I've shared. Okay, let me check.
I mean, just check, please.
Let me check. Oh, I think it disconnected. Okay. Yeah, sorry. Let me do that. Are you able to see?
Yes, now it's visible.
Are you?
Yeah.
Oh, okay. Yeah, sure. Not sure how it got. Um, okay, fine. Okay, I was basically explaining an image in a three-dimensional space. It has three colored channels. This is how we are representing the any okay, and using those input columns, we're trying to predict the sixth column, which is y. Right. So my mathematical equation can be represented as a1 x1, a2 x2, a3 x3, a4 x4 plus a5 x5. This way I can represent my mathematical equation. But if I talk about an image data, how do I represent this? In the image, let's say I want to identify whether there is a cat or a dog or a human. Okay, object identification. Or you can say tumor existence or non-existence. Image recognition is being used to identify whether a tumor that we are trying to diagnose is cancer or non-cancerous, malignant or right benign. So your label that you talk about, your output, let's say is yes or no. Okay, or cat or dog or tumor or no tumor, whatever that is, right? Yes or no, binary output. And the input that we're talking about here are the images. There will be n number of images, that would be your data, but each image that you talk about is or can be represented as a row by column data, a two-dimensional object. And I cannot use this image, a two-dimensional data, directly for this equation, right? So what I do, I have to flatten this rows and columns. I have to take each cell in this pixel separately, individually, right? So if I say a 28 megapixel, 28 by 28 megapixel image is there, that means how much is this? 28 by 28. How much is this? 764, is it? Somewhere around here, this one, whatever the calculations. So those many inputs will be there. That means your equation is extending to those many values, right? So that's a big challenge that we have to handle here. Parameter explosion, we call it as parameter explosion. Even if you talk about neural network algorithm, a perceptron algorithm, then you have to pass 764 inputs, and you'll have to have those many weights plus one, of course. Bias would also be there, constant. So in total you'll have 765 or 765 variables. It's a huge mathematical burden, right? So the challenge here to handle with images is that you are trying to train your mathematical model on individual pixels, right? And there is no other option rather to use a technique called as CNN, which is called as convolution neural network, which basically convolves the image into a lower space, lower dimensions. And here we use something called as filters to convolve the images, right? So there's certain formulas and all those things used to handle the convolution neural net or handle the images. And your neural network is broadly classified into three types. A and N, this is generally used to handle structured data. Artificial neural network is the basic foundational right neural network algorithms that we develop. Then we have something called as CNN. This is designed to handle images because you have so many variables, right? You'll not be able to directly work with ANN. Hence, we convolve the images using filters and we handle CNN. Then we also have something called as RNN, recurrent neural network. This requires to store the data. So anything which is sequential data, like your audio or your video, anything which is sequential text data, we use RNN techniques. And there are variants in RNN techniques as well. And yeah, these are the deep algorithms, deep neural net algorithms that are being used in the industry right now. And variations of them. So RNN is used to handle videos or text data. When you open your Gmail, for example, in Gmail, when you try to write an email, what is happening? You get prompt, right? Gmail is prompting you. That's basically an algorithm which is trying to predict the next word prediction. Based on all the previous words, I mean, all the emails that you have written, the way you type your email, not just you, but a lot of people, there will be certain pattern of words which always occur in a order. So identifying that pattern is the job of your RNN algorithm, and that's basically used for next word prediction in email also, right? But chatbots example, a lot of chatbots are being built now. There's something called as generative chatbots. Generative chatbot means it's more like a human, not a dialogue based, not predefined set of intents. No, this generative chatbot is an AI chatbot which uses a concept called as NLP, natural language processing. And this concept basically is used to have a conversation just like you have a conversation with a human being, naturally, right? And we use CNN, RNN, all those things as part of the generative chatbot approach. For example, if I show an image to a chatbot, or if I start conversation with a chatbot related to, let's say, a product. If I show an image using CNN algorithms, right, image recognition algorithms, your chatbot should identify what is there in that image. Probably you are showing a, okay, this is something that we worked some time back. Let's say in a restaurant, okay, we did work with Paradise Food Court. So people who are from Hyderabad, if you are from Hyderabad, you know how famous Paradise Food Court is. Paradise Biryani, it's very famous here in this part of India. I'm pretty sure in Chennai we have Paradise branches. And yeah, in Bangalore, I know for sure they have. So biryani, right? So a very famous restaurant. Now let's say I visit to one of the restaurant. It may not be Paradise, it could be any restaurant. I visit to a restaurant. I might have seen, right, and let's say nice item, nice menu item. Probably one of the chefs who's working in that restaurant is doing that item. He prepared that item in a television. So I took a photograph, right? And I go to the restaurant and I should be able to identify what is the name of that particular item by looking into the menu items that are there in the restaurant. That is one use case, probably. Uh, you might also say by looking into this image, right? You need to identify the objects, what are the ingredients that are there in that item. So these are the kind of complex use cases are being solved by these kind of algorithms or chatbots. So I would say and I ask what is the item of that particular or that name of the item. Now chatbot should look into that image and identify what is that particular item and what is the cost of that it is an item which is specifically made only at specific point of time, then that information should be shared to me. Now, I'm asking, if I ask a waiter, obviously he'll give me all those information, right? I don't want to talk to a waiter, I want to talk to a chatbot. From a restaurant perspective, I can reduce my staff, I can reduce investing on my staff, I can invest on the chatbot, and I can basically go global as well, right? People don't have to come to me to order the food. I can deliver the food as well. So a lot of business advantages will be there for that kind of a application. So by passing the image to the chatbot, I should be able to identify the product. And I'm trying to have a conversation with the chatbot. So I'll say, hey, hi. I upload the image and I'll say, hey, can you identify what is the item? Name the item. So chatbot names the item. Then I'll say, what all products or what all ingredients does this item has? I'm saying this item. What is this? If I speak to you, you'll be able to understand because you're a human being. I mean, we have that intelligence, right? Humans does have that intelligence. We will be able to map the entire context, right? The flow. Isn't it? So just like a human, can I try and get this identified by a chatbot also? When I say this, the chatbot should understand that the user is asking about the item that he has tried to get the information about. And then it has to give the information about it. Do you have any other options? Any other or variants of the same product? Do you have any other options? So that means you also have to identify, do we have any other variants of the same product? Probably some ingredients have changed and then we make those items available. So it's just like a human to human conversation, right? Now this generative chatbot that we are speaking about should be able to identify the images and it should also be able to identify the context of the conversation. So here we use CNN, we also use RNN, hybrid methods, right? Now in RNN, what happens is, in CNN, we are trying to reduce the number of parameters. It is convolving the images and then trying to train on the images which has very high input set. And when we talk about RNN, RNN should have memory so that it keeps track of what all things it is like learning. It's not like learn on this, forget about this and try to learn new thing. No, it's a sequential data, right? So in order to remember that context, you need to keep a memory. I mean, you need to keep track of all the things that you're learning. So RNN will be like a memory banks. You can treat them as memory banks, and they have a storage space where they keep information. There is a mechanism, not storage space, sorry. It has a mechanism to keep track of all the things that it has learned till now. And if you learn all this and keep track of all this, then the next thing can be easily identified. And yeah, image captioning, then next word prediction, the email thing that you're talking about, all those things can be done using RNN. Right. So about the variants of neural network, friends. So we have three variants: ANN, CNN, and RNN. Okay, at a high level. And any time, right, when we talk about images, always remember images consists of features. I mean, if I talk about a human image, in order to identify who's that image of, then you need to first identify a high-level features like eyes, nose, right, lips, ears, hair, mustache, everything. Right, and these key features can be identified along with your edges. Edges means the boundaries. If you can identify the boundary, the object can be easily identified. And then within the edges, we have pixels. So this is the hierarchy level of breaking down of learning process for any image. CNN algorithm, it takes pixels. Within the pixels, along with the pixels, it identifies edges, and along with edges and pixels, it identifies high-level features. And based on those features, it identifies what is that image all about. Right? So same way, letters, words, sentences, high level, right? I should say, understanding about the text data. I see there is a message. Let's look into that message before I go to the next level. Okay, we're talking about attendance. Yeah. All right. So when I get text data, how do I process it? Now, when we talk about any text data, it is in unstructured format, and majority of the text data can be seen nowadays, which can be captured from all these different sources, right? And social media is the most important source where majority of the data that we are seeing in textual format today is generated here, right? Majority of it. We have call transcripts. This is a little, I should say, memory lane. We go back memory lane. When these neural network algorithms, deep neural network algorithms are not that mature, we did not have algorithms to process audio, voice data. So call centers, they collect a lot of data, right? Even today, if you make a call to any customer care executive, there would be a warning message, right? There would basically an informational message says, the call is getting recorded for quality purposes. They record that audio, the conversation. So prior to these latest technological advancements in the space of AI, when the algorithms were not that mature enough, in order to analyze the conversational data, the call, the voice that we have, right, used to get converted into text format. Voice to text softwares were used to convert the data which is there in voice into text format. And we used to have your analytical models, NLP, or you can say text-based algorithms, which were used to process that textual data to understand the quality of the executive, to understand the service request itself, why the service request was raised, and all that. A lot of processing was done on that text data. So that's called transcripts. The another advantage with converting the audio to textual format is the storage space, right? Because audio takes a little larger space compared to textual data. Okay, so that is also another reason why organizations convert their audio data into text data and archive it. For archiving, you don't need so much of storage, right? So compress and store it in the repository. So that's call transcripts. Then email to customer service. When you're writing an email, obviously it is in textual format, right? Service desk. They see a lot of these emails. They read that email manually and then identify what is the severity of that service request, what is the priority, right? We need to set the priority, and then we need to assign that particular service request to an appropriate team. Based on the content, the executive will read that service request and then assign it to or route it to an appropriate team. There will be a lot of textual data. So how about doing service desk automation?
Hello, Mr. Sharath, can you hear me? Hello.
Connection lost.
Hello. I think he's lost his connection, so please wait. We are just contacting him.
Hello, madam. Can you not take the attendance through Google Meet? Like I attended other programs also, they are taking like that instead of
We are
disturbing
taking
all.
attendance. Yes, Professor, we are taking attendance in the Google Meet also.
Because this is
We are taking,
disturbing.
we are downloading, we've taken from the Chrome Web Store.
Please.
We've included Gmeet. So if you have not been able to fill the Google form, please don't worry. Okay.
Ma'am, what about yesterday evening session attendance? I have not filled in the Google form
If you have been here in the class, sir, don't worry. We have Gmeet attendance.
because
Right.
voice was not clear in the entire session, so I was not
Yeah, but
able to
then
listen anything.
we posted in the WhatsApp group. No, are you there, sir?
Yes, madam. Like, madam, like
Yes.
it's good that like you are actually doing a nice job.
Yeah.
What it is on a daily basis you can post the attendance so that people will be confident. Yes, it's already marked.
Okay. Okay. Yeah,
Uh,
we can do that. No issues.
so that is good enough, I think. Like
Ma'am,
nobody.
please share the attendance link on the WhatsApp also so that we can mark.
Where in the this thing in the Google Classroom you are saying?
No, in the WhatsApp group.
We posted yesterday.
No, yesterday.
No, it was posted. So please let the session be over. Actually, the speaker feels like in the chats, everybody is just asking for attendance. So please, we'll share by 1 p.m. Don't worry. And we
Because
are having the attendance from DMeet.
right,
Okay?
good. While
Yeah.
the class is going on, so much of disturbance because of attendance and all that.
Yeah, I know. I mean, the speaker might think that
Right,
people
exactly.
are just worried. So don't worry, we have GMeet attendance.
Sure.
So it's
Uh,
recorded there.
Ma'am, on the WhatsApp group, you have shared only morning session attendance yesterday, not the evening session.
Okay, so if you have not filled, we'll share the link again. We'll open it. You please fill it, okay?
Okay,
Otherwise, as
ma'am.
I told you, we have in the GMeet, sir. So if you are attending, need not worry about it.
Okay.
Yeah, we have the record. I think we've lost, Mr. Sharath has lost connection. I'm trying to contact him on phone. Please be connected. Okay, thank you.